this lab, we wanted to find out at what position and time two cars would hit if they were released at different times and had different speeds.
We released one car 2 seconds later than the other, and we calculated when they were going to hit, both algebraically and graphically. And we're going to show you how! So when we were calculating how long it took for the cars to travel across our total distance, we had some inconsistencies due to the fact that the cars would turn and occasionally hit the wall, causing friction and slowing them down. The way we tried to counter this is we took 3 runs of the cars and then we averaged them. So you just add up all 3 times, divide by 3, and that's how you have your times.
So to find the time that the car A and car B hit each other algebraically, we first did our total distance was 2 meters. So car A went 5.16 seconds over 2 meters, so we divided that to get 0.38 meters per second. And then the same thing with car B, and we got 0.44 meters per second. And then to find the time, we did distance equals velocity times time. So here we did 0.38 meters per second times time. And then for car B, we did 0.44 meters per second times t plus 2, because we decided to release this car 2 seconds later. Then we did some algebra and distributing, and in the end got 0.82t equals 1.12, divided both sides by 0.82, and got 1.365 seconds, and then added the 2 seconds when we were going to release car B 2 seconds after, and got 3.365 seconds when they would hit.
Christian found that the cars were going to collide after 3.365 seconds, and so we used the formula distance equals rate times time to figure out at what distance they would hit. So we used the rate of car A, which is 0.38 meters per second, and multiplied that by the time, and we got 1.2787 meters. Another way to find what time and what distance they'll hit is by graphing the lines of the 2 cars. And so we used the rate of car A, and it started at 0, 0, to find the graph of its line. And then we graphed that, and then we found the graph of car B's line by using its rate, and found that line and graphed it, and they intersected at 3.6 and 1.25, which is really close to our analytical information.
After finishing the experiment, our little margin of error was over the couple days that we did this experiment, the battery went down a little bit on our car, making the times go off a tiny bit.
However, that being said, our hypothesis was still relatively precise.